Cool, so we're gonna get started. You all can hear me, right? Cool, awesome. So my name's Mike. This is Ted. We work at Facebook on the security team, specifically on operating system security, and we really like OS X. So we're gonna talk a bit about OS X operating system security and how we approach that at Facebook and some of the tools that we have to do that performantly at Facebook's scale.
Cool, so a little bit about our infrastructure. We have about a little over 12,000 Macs, 16,000 Macs that are used by developers, employees that work at Facebook, sometimes contractors. If we bring like an assessment team on, they'll get a couple Macs to use while they're here. We also have a couple thousand worth of production Mac hosts. And those are running performance and regression tests on all the apps, the family of apps that Facebook produces. So you can imagine developer makes a diff for the Facebook iOS app. They push that diff. It lands. A machine checks out that build, runs it for 30 minutes, monitors the performance, and then reports back if the performance was greater or less. Right? And those are all continuously building. Those apps, they're probably at about 60% workload all the time, which is exactly where we want them. So our security stance is kind of broken into three parts. Production hardening, so that's making these things safe to use, pushing out managed policies, protecting the firewall, and protecting the corporate to production boundary. Client engineering, the gentlemen in the back here who do awesome work and make all of our machines run and prevent like us from getting crash reports. Thank you guys. They're a large part of our security. They are rotating keys with file vault. They are pushing out the managed policies that everyone in security argues over and eventually agrees on, right? And then lastly, there's the intrusion detection. So like kind of the black art of the security workflow. And that's kind of where we sit. There's about 10 of us, right? About 10 of us that do intrusion detection and incident response for all of Facebook. So that's the 16,000 Mac machines, the, God help them, couple of Windows machines that are out there, the kind of like corporate IT machines, so our firewalls, our VPNs, and then all of our production infrastructure. Mostly CentOS, and that runs the facebook.com, www.facebook.com, as well as thousands of services that power facebook.com. We do intrusion detection for all of that. So what do we mean when we say intrusion detection? We're looking for bad guys, so we're setting up alerts. We have an incident response kind of queue. We have our own custom system where we can all participate in event management. What's a good? So if you had Splunk deployed and then you wrote alerts in Splunk, whatever tool you're using after that to manage how you respond to those alerts is kind of where we spend a lot of our time. And what we're doing in there specifically is like, we can't really explain it because it's all across the gambit of looking for people who are inside Facebook abusing their power. We're looking for like espionage attacking our production fleets, espionage attacking our client machines, as well as people trying to defame Facebook. People don't like Facebook. They don't agree with the mission of Facebook. I can't imagine that would ever happen. Like, that's actually theoretical because no one actually hates Facebook. No, yeah. Don't worry. All right. You can sleep at night, right? And also mass malware. So mass malware is like the drive-bys that you see. So Adobe Zero Day came out from the hacking group that was compromised. That gets rolled into Metasploit. Eventually it'll get rolled into some watering holes. Those that are browsing the internet, the innocents, could possibly get popped. They could get adware on their machines, or they could get enrolled into botnets that are doing like DOSes. We care a lot about those because it's pretty trivial to get them to pop on a machine, and it doesn't really take too much skill for that to happen. So you have eCrime using that to get persistence on boxes, and they don't really care that they're at Facebook, but when they find out that they've popped a machine that belongs to Facebook, they can then sell that access to someone who's going to use, who wants access to Facebook. So that very quickly escalates and turns into a situation that like if we haven't remediated it by looking at the malware, we have like a massive problem on our hands. And like, of course it goes on, right? Think of your best security problem. So we include response in this too. It's also our job when we do detect something to go through the remediation. And that would be like getting an image of that host. If it's in production, taking a snapshot of that production machine or the production job, the container that's running in, or grabbing the laptop, grabbing the desktop, imaging it, pulling it back, doing forensics on it. So that's our kind of responsibility. So because there's so few of us and a massive number of machines, right, it's really important for us to extract as much signal as possible. Anytime we kind of like spend a day researching something or spend a day responding to something, we have to create signal from that because we don't want to spend that time doing that again, right? That would be a waste of our time. And when we do choose to investigate something, that we have to have a lot of confidence that whatever signal we had extracted before, whatever IOC we're acting on, is like of extreme value to us, right? If there's things that are coming out with false positives, we need to squash them as soon as possible, right? A false positive for a 10-man team defending all of Facebook's infrastructure, that's bad. That's very bad. But that's very, very hard for these extremely variable, and I'll use extremely because we've been doing this for a little bit of time, OSX clients, right? You all know people who use OSX. They like to do a lot of cool things. They don't like their machines locked down. You get a bunch of developers at Facebook, they're really awesome engineers, right? They know these operating systems inside and out. They know their favorite applications. There's no chance that one machine looks like another. So trying to perform anomaly detection on this is almost impossible, right? One machine compared to another, it looks very anomalous. So yeah, and then we talked a little bit about the avoiding duplication, but when we step back and think about a 10-person team defending a massive number of Linux hosts and a massive number of OSX hosts, it's kind of hard to specialize. And then we do on-call rotations too. So at any point, you could be responsible, you could be like an incident handler for the entire set of machines. So it's very important that you know how to defend OSX as well as Linux. So when we create tools, when we create workflows, when we create signatures, when we look for intelligence feeds, we have to make sure we think about both platforms. So if we were going to buy something, if we were going to buy or subscribe to something like Snort signatures, right? We don't want to deploy those Snort signatures specific for our enterprise or corporate firewall egress points, right? We want to make sure that anything we purchase kind of scales to all of the machines that we have to protect. The same goes for storage. When we're logging data from our OSX clients, it's very important that we kind of put this into the same place where we're logging everything from our Linux production hosts too. As soon as we create two places to retrieve data, that's two things that a defender has to do, right? That's a waste of time for them. And that's also kind of hard too, because there's a massive boundary between what we consider production, the things that run Facebook, and what we consider our enterprise or our corporate network, the thing that all the Mac clients are connected to. So we have to create little gateways and like push the data someplace. We choose to push it all into production. We feel that's the safest. We have the most infrastructure there. So whenever we need to log something on an OSX client, it's important for us to kind of eventually pull it into production. So we can use all the tools on there. We talked a little bit about clients, right? And I haven't really mentioned anything about network or like network intrusion detection. Partially because I'm very bad at network intrusion detection, but also partly because we like to We have this motto of focusing on the client. And that's like Mac and Linux laptops, because like we just said, they're the most variable, the largest attack surface, they're cruising the internet all day, and they're the highest risk. So the highest risk because attackers want the client laptops for two reasons. One, they want to defame Facebook, or they want a gateway to go into our production infrastructure. And if you compromise a laptop, chances are it's only a matter of time before you'll get into production. You have to sit and learn, so it is a matter of time, but you will be able to hop into production if you're a sophisticated attacker. But also, these laptops are used by our engineers to do personal things too. So there are passwords that they have stored in keychain, credit card information. They're in Outlook, all of our contacts, right? So the swath of attackers that are looking to land on one of our client machines is much larger than the swath of attackers that's looking to like defame Facebook or get into our production infrastructure. So that's why we rank these highest. Clients are the highest risk, but they're also kind of the hardest to defend. And we'll spend the rest of the presentation kind of defending that argument. So I said I'm kind of not that familiar with network-based IDS. So my previous jobs, I worked for the government. I've never really got a chance to dive deep into the network. We would mostly just purchase a machine, stick it into our network, our egress racks, tap and tee the network line, and pass it to this magic blinky light box. That would create a data feed. We'd slurp that into Splunk, and then we'd install the Splunk app that had all the alerts and would put it into our incident management queue, and then we would just kind of click yes, no to all of that. Didn't get a lot of opportunity to learn about what's happening on the network, but it got the job done, right? And at the end of the day, that was the most important. When we tried to start looking towards defending hosts, and when this is about 3 years ago, and the government was first bringing OS X into their enterprises, we couldn't find one intrusion detection software that would work on OS X. Like, we went for MacV and a SEP client, and then we went after that to Encase, and every time it was just a massive onslaught of like these gray screens of death, right? We had our on-call rotations working in the government was sitting with our help desk and trying to restore these machines to where they had left off. It was our responsibility because we had been crashing them because we had installed the clients. That's really troublesome, right? That's really troublesome because it creates an environment inside your enterprise where people are kind of against security and they see us as getting in their way. So they'll create tutorials and walkthroughs like on our internal wikis about how to uninstall these clients. How to uninstall the clients all the way to how to patch a bit of memory such that the client thinks, or the machine thinks it's on, but it's not. So like if you're gonna put up a VPN that requires an antivirus agent to run, now you can't just uninstall that antivirus because then you can't connect to VPN. Well, if you patch a bit of memory in the VPN client, it now thinks the antivirus is running and you get away for free. So that's how bad it was, right? So it became really important for us, if we wanted to defend a host, to really think about the experience the entire enterprise would have. And that's trying to do like testing for each one of these really variable environments that the host might be in. It's almost an impossible situation, right? And what it led to is we didn't deploy any host intrusion detection software anymore. So why is that? How did we get into this state, right? Well, inverse, we probably had 20 to 30,000 Windows machines. And every time we wanted to install a new client there, it went off without a hitch, right? Go to Enterprise Change Management Review Board. And instead of demonstrating that your client worked on all the Windows versions that you supported, you kind of raise your hand and say, yeah, I've got this new client. Can I install it? Absolutely, go for it, right? there wasn't too much pushback there. Right, and that makes sense. If I were selling a security product, I would make damn sure it worked for Windows, right? And then when it came to OS X, if one of my awesome customers that had a lot of machines wanted it, I would tailor it specifically for their environment, right? It's just like a cost trade-off, right? So and then the few that were instrumenting OS X and Linux hosts, yeah, I should edit that and take Linux off. But the few that were supporting OS X were massively expensive. Talking like $30 or $40 per agent, per machine. $30 or $40 times our 16,000, that's not gonna work. And they would be tailored for all the medium to large like infrastructures and all of their products too. So you have OS X client software that's pushing stuff back through Open Directory into Active Directory, right? So if you ever tried to manage your OS X clients in like a completely OS X way, or completely Apple way, you're boned here too. All right. So I'm going to kind of get off my soapbox and say like why the state of host intrusion detection for OS X sucks, and get into some more like happier thoughts. When we sat down and said, all right, enough's enough, we're going to try to build something that solves all these problems. And we're going to try to build something that solves all these problems, not for just us and where we are right now, which happens to be working at Facebook, but when we leave and go to our next enterprise, or we hang out with our buddy who's working at, who knows where, it's something that they can use too, right?
Cool. So we've talked a bit about host intrusion detection and specifically why it's a hard problem on OS X. So about a year and a half ago, a bunch of us at Facebook Security kind of sat down and started thinking more heavily about what we can do to improve the security posture of our clients, right? So we kind of enumerated a bunch of desired properties of our ideal host instrumentation software. And we came out with 4 really big properties that we wanted whatever host instrumentation software that we went with to embody. And that's simplicity. It needs to be simple to use. A lot of host instrumentation a lot of host intrusion detection systems that you'll come into contact with are pretty complex. You have to write some moderately complex code to accomplish some moderately trivial tasks. And it's really hard for new people that haven't used that piece of software to ramp up to using it. So it needed to be as simple as possible so that people felt comfortable using it extensively. It needed to be really flexible. So at Facebook, we have in production, we have a lot of computers that run in our production network, surprise. And we have a lot of pieces of software and infrastructure that we use to write really scalable infrastructure and really scalable software that we run in production. And that might include, distributed logging infrastructure where our logs never hit disk. We use something called Scribe. We also use a distributed configuration management piece of infrastructure, which is kind of like a modified Zookeeper that we use to distribute configs across production. So we have all of these things that we use to create really scalable software at Facebook, and it would be unreasonable of us to expect to deploy software in production that doesn't take advantage of those things. So that was a big deal, and we needed it to be performant. We needed something that we can run on both, like Ted said, on both OS X and in production Linux. And our production Linux consists of the servers that generate your news feed. Your news feed can't stop working because we were trying to see what packages were installed on those hosts, right? So it needed to be really reliable, really performant, very flexible, and really easy to use. So we kind of wrote down all these things that we wanted, and we took a look at all of the products that were available for us to purchase, and none of them allowed us to check all the boxes. None of them really allowed us to check most of the boxes. So we decided, in typical Facebook fashion, to build something ourselves. And what we came up with was something that we call OSQuery. So OSQuery is SQL for your infrastructure. Who's a fan of SQL? Cool, that's more hands than I expected, actually. So SQL, for better or for worse, is something that many of us are pretty familiar with, and it's a pretty simple query language. So OSQuery is SQL for your infrastructure. So you can use SQL queries to explore data about your operating system. Now, in a normal database, a table will represent, like formatted file on disk. So if you do something like select star from purchases in a MySQL database, there's like a big file on disk that has your whole purchase history, and the MySQL query engine is going to go through it and pull that stuff out from disk and return it to you. Now, instead of tables representing these kind of pre-formatted structured files on disk, in OSQuery, SQL tables represent abstract operating system concepts like kernel modules that are loaded, processes that are running, launch agents and launch daemons that are currently loaded, firewall settings, right? The list goes on. So let's talk a little bit about why SQL, how to use it, and what's awesome about it. So operating system concepts are shared across many different operating systems, right? Every operating system that we use has processes. Every operating system that we use has a kernel and loaded kernel extensions or modules. And all of these concepts have pretty similar attributes. For example, every operating system has users. Every user has an ID. There are file descriptors on every operating system. Every operating system with a network stack has ports. Every operating system with a file system has file paths, right? There are all these attributes about operating systems that are pretty standard across OS X and Linux. Like we said already, most developers and administrators already know SQL. So it's starting to get pretty fun. So let's look at an example. Let's kind of walk through building a query. So start off with select PID, name, UID from processes. So processes is an operating system concept, right? And that concept has attributes. Each process has a PID, a name, and a UID. Now, if we want to limit the kind of data that we get back and ask pointed questions of our operating system, we can do that by appending query constraints. And to get really fancy, we can join that information on other tables that expose the same columns. So if one table exposes a UID of a user that's doing something, maybe it represents like you have a users table, which has every user, and the primary key of that table will be a UID of that user ID. Well, if another table also has a column that has user ID, you can join those two tables together and contextualize the information pretty fancily and add attributes. So username is from users, PID and name are from processes. It's a good time, right? So there's a lot of tables in OSQuery. There's over 100 tables in OSQuery. So there's a lot of data about your operating system that you can really easily access via SQL, and it's really fun. So we highlighted some that might be especially interesting, like homebrew packages, browser plugins, things that are plugged into USB, processes that are bound to network ports, changes to files at certain paths that you care about, devices that are mounted. It goes on. It's pretty fun. I'm getting a little happy here. So the key thing here is that each of these tables represents something pretty simple. And the reason why we have many simple tables instead of fewer complex tables is because, like we already said, if you have a users table that exposes a UID of that user, then every other table that exposes a UID of a user who's performing an action can be joined against that table, and now you can contextualize any other table with all of the information from there. So simpler tables are easier to write, they're very compartmentalized, they're much easier to maintain because it's easier to reason about what the table's doing, and they can be used in many contexts by joining the tables against other cool stuff. So one important thing to note is OSQuery is a lot more than just a security tool. Literally, it's a family of tools. So OSQuery is kind of like an umbrella name for a bunch of tools that we distribute as a part of a pretty neat package. So I'm going to talk to you about one, and well, we're going to talk about a few, but I'm going to talk to you about one. So the first tool that I want to introduce you all to is called OSQuery I. Who can guess what I stands for? You get a t-shirt. Except I didn't bring t-shirts, so don't follow up on that. So let's look at some things that you can do with OSQuery I to try and ingrain how OSQuery works by just looking at some pretty simple examples. So this query that you're seeing here, select star from time, You're just echoing it and piping it into OSQuery, and that's just one of the ways that you can execute queries with OSQuery. And it returns 1 row, 3 columns, hour, minutes, seconds. So you can see I was up late one night when I took this screenshot. It was 12:58 in the morning. So that, if I would have executed that query right after that, 2 seconds later, it would have been 12:58 and 32 seconds. So the data that OSQuery generates for you is generated at query time. So when you run the query, you're running this query that's accessing this information about the operating system exactly when you run it. So it's always up to date. It's really fast. So when you execute a query, it identifies the machine code that's going to acquire this information about your operating system, executes it really quickly, and then returns the information to you as if it already had that information prepared. So to you, it's kind of seamless that this is happening, but it's actually working the moment you run the query. So we keep this table time in there, not because it's an especially useful table, because it's really good at illustrating that OSQuery is generating the information that it returns to you every time you execute a query. Now, let's look at something that's actually useful. So this is really hard to read. You're not really supposed to be able to read this, so don't worry too much about it. We'll post the slides online. But basically, this is a query which identifies all of the launch daemons which run a binary when your Mac boots. So we have a table called launchd. Everyone's familiar with launchd, right? We have well, if you're not, launchd is like Linux's init on steroids, or like cron on steroids. It's awesome for the most part, and it's how work is scheduled on OS X. Launchd, the process, is actually the first process that, the first process that starts on OS X, and it takes care of launching everything else. So launchd is manipulated by scheduling launch agents and launch daemons. And they may have actions, like you may say, all right, this launch daemon is going to run whenever my computer boots. And when the action that it's going to take is this binary. So if we want to see all of the information in launchd, we might say something like select star from launchd. But we only want the binaries that are being ran when your computer boots. So we'll say, all right, select star from launchd where run it load and keep alive are true. And we can kind of keep tacking on these query constraints until we have the set of information that we're really happy with. So this specific query is selecting the name and the executable from launchd, where launchd is running that executable at boot, and the executable exists in /system, somewhere below /system. So this is the list of system binaries that were scheduled to load on boot on my computer at the time of the screenshot, right? Cool, neat information, really awesome. This one you probably can actually see, hopefully, but what it's doing is select path and PID from processes limit 10. Just give me the first 10. So just give me the path and the process ID of the first 10 processes that are running on my computer. And we're not ordering by anything. We're not sorting the results that are returned. We're just saying like, hey, of all of the processes, give me the first 10 that you get. And actually, the implementation of the processes table uses the libproc API. And the way that the results are returned from that API are in order of most recent process creation. So if you see the first process that's executing, or that's being returned in this query results, is user local bin OSQuery. And that's actually the OSQuery process that's executing that query. So it's kind of inception-y OSQuery on OSQuery. It's always fun. I always like that slide. So the processes table is really cool, and similarly to how the users table exposes the UID of the user ID, the processes table also exposes the process ID, the processes table. So there are other tables that expose process IDs, and we can join them together to do some pretty cool things. For example, there's a table, again, I'll explain this. Don't worry about seeing the specific text of the query. But there's a table called listening ports. And each row in the listening ports table is a network port that's being bound to by a process. Now, a process may bind to 0 or more ports, right? A process can not be binding to any network ports, or it can be binding to several, and it will have several rows in this table. Each row in this table exposes the process ID of the process which is actually doing the binding to the network port. So by joining the listening ports, by getting information from the listening ports table, and then joining that with the process table, we can then contextualize every line there and get a lot of information about all of the processes that are listening on network ports right now. So we got a lot of TextMate, we got some Spotify, we have ARD agent, we have a lot more Spotify. Big Spotify fan. So we've only gone through, what, 3 or 4 tables in these examples so far. Like I said, there's over 100. So there's a lot of really cool and interesting stuff that you can do with OSQuery. Now, OSQuery is just one part of the puzzle there. So I'm going to hand it back over to Ted. Ted's going to tell you about another really awesome part of the puzzle.
So let's get our hands dirty. We actually got some time, right? We use the development version. Please, nothing go wrong. All right. So Mike was saying this is an interactive shell.
You're not on the screen.
I'm not on the screen?
No.
I will be in a second. Did I go? What's that? All right. So instead of piping stuff to OSQuery, we can just launch it and we'll drop into a REPL. And this is just like a read line loop with like history and awesome stuff. So one query that I just ran, PCI devices. Here are all the PCI devices that I've attached. The Thunderbolt cable that I attached that I can project onto the VGA cord is now in here too. Right. Similarly, USB devices. And then limiting that to just do, let's say, vendor model. This is awesome. I love USB devices because we work in a little group of 10 security people. We like to kind of screw around with each other every once in a while. Wireless mice, usually the Bluetooth receiver is super, super small, fits into the side of a monitor without you noticing, and then maybe 10 minutes later while you're digging through some code, your mouse just goes everywhere, or the 2 buttons get swapped. Yeah, that's pretty annoying. So monitoring for changes to your USB devices and sending yourself an alert is awesome to catch those hooligans when you're out to lunch messing with your monitors. I love that. Let's see what else we got. So we haven't yet talked about how OSQuery is solving like security problems yet. And just hold on, we'll get there. But before we go into deeply on how like we deploy it and how we use it to catch bad guys, let's talk a little bit about how you can use this for like automation, like other things other than just security, right? Apps. So the apps table uses a bunch of like well-known paths as well as the NS Notification Center APIs to find out when a new application is dropped onto a machine. You could use OSQuery to, even within like all your other scripts, just piping information to it, and then --JSON getting that out, or --CSV, or there's a bunch of forms to get it. You can output in HTML too. And kind of like act on a new application being installed as you run that query. The same goes for like, what will we call here? What's a good one? New users being installed, or changes to file systems, changes in the network perspective. Like the kind of idea we're trying to pitch here is when we say like, hey, this is not just a security tool, you can use this everywhere. And we kind of want to support that. And we want everyone who wants to like kind of write an integration for OSQuery to kind of ping us, right? Throw the idea into our mind. Maybe we can help you with it. Throw an issue up on GitHub. But let's talk a little bit about like those queries and using them to find like badness, right? So, okay, we can kind of play around, explore with these queries, join a bunch of stuff, put where clauses in, limit data. What happens after you found like the perfect query, like that massive query that Mike had up there, which found all binaries that were launched by launch date? What do you do with that information? Or how can we get that in a way that we can act on it? That's something we call OSQuery D. All right, another non-existent t-shirt for whoever gets what D stands for. Whoa, yeah, awesome. All right, here's t-shirt. You didn't catch it? Oh, come on. Yeah. Right, so if I were to jump back and select name from processes, or name like query. So I have two OSQuery Ds running and the development OSQuery I shell that I just ran. So that OSQuery D is running on every Mac laptop that we have. That's what does the magic. So that translates those queries into an event stream. And it reports back changes to those events over time. So imagine this. You come up with that awesome query, and you're really interested in the results in the first time you run that, but you're not so much interested in the results every time you run that. That's a lot of duplicate information. What would be awesome for you is to know when launch daemons that execute a binary are added or removed. So we call this a schedule, the schedule of queries to run. And the schedule is just that query that you came up with, and plus an interval to run it on. So for launch daemons, a good time to run, to look at launch days, maybe like every hour, couple hours.
10 minutes an hour, yeah.
Right. And then you want that schedule to output the changes, right? And that's what we bring back into our log aggregation. That's what we bring back into Splunk. That's what we'll throw into Elasticsearch, the changes. And we'll amend or we'll append like an added or removed to whatever lines get removed from the launch daemon or added. And that output kind of buffers to disk, goes to syslog, and then you pull it up with a log forwarder like the Splunk Lightweight Forwarder, FluentD, whatever you're using right now. And then we can perform our kind of analytics after the fact. So when we do, I was saying before, like we purchase some IOCs, like indicators of compromise, malware lists, right? And we put all that data into Splunk too, and then we can run our aggregations on the names of the binaries, the paths that get output from this query schedule in Splunk afterwards, right? There's another capability that this daemon gives us, which I kind of hinted at before, which is viewing your operating system as an event stream. So Mike talked about running a query in OSQuery and having that query execute. So we want to list process. We make a couple of syscalls that ask the kernel for the process list, and then we kind of look at the paths, the user IDs for them, how much system and user time they've used up, and we report that back. That's what we call query time. You ran that query, we did the introspection, and then we log the output. There's another concept here, which is like how things are happening very quickly on your operating system, where query time doesn't really make sense. And that's like you're editing a file, or you're connecting or disconnecting from a network. An application is launched. Spotlight found a new application. And we call those like event streams, and we support those too. So just as we try to like increase our velocity in the number of tables, the number of operating system concepts that we support, we also look into these like operating system event APIs, and we try to wrap them too. And then we'll expose them as tables as well. So you'll see a couple of tables that are like underscore events, like file events or network events. And while the daemon's running, it's hooking those APIs and it's recording all those events for us. Then we come in at query time, and instead of asking the operating system for structures, we ask the log of that event stream for structures. So you still get the power of writing all those where clauses and joins on the event stream, but we're logging all that event stream into like a high performance database. #RocksDB. So now you can run queries at like the concept of query time on the evolution of your host. And then we apply the same schedule to log the changes to that back to Splunk. So if I want to know anytime a binary gets written to /user/bin, I can now query where path like /user/bin from file changes, and I'll know the exact time that anything was written there, but I'll only have to log that like once a day. Right? I only have to pull that back once a day. So this is kind of like the maximum flexibility that we could think of. And then when we're considering like how often you want to pull data back, where you want to buffer data, we also think about like how you would want to configure the daemon. So when we say configure, we're changing all these little like intervals and times, the user that it runs as, the query schedule, right? So the big list of queries that you're going to run and the interval. And we kind of came to a problem, and that was, hey, our mission was to get 10 people to support a massive production Linux fleet and a massive OS X fleet. Our Linux fleet cannot read stuff from disk, right? That's not going to happen. It can't log stuff to disk either. A lot of them may not even have disks. And then everyone else we were kind of working with and asking questions of to help us build something that would work in their enterprise, they also have these like weird integrations. So we came up with this plugin system, right? Like every good piece of software has a plugin system. And this allows us to kind of abstract the concepts of configuring the daemon and logging from the daemon. So if you want to configure by fetching something from some HTTPS host, fine, right? If you want to grab something from our configurator example, the Zookeeper example, awesome. If you're going to place something on the file system through like Chef, and that's how you want to read your configuration, awesome. We want to support all of those. If you have weird things too that you do internally, there's a way to write some Python code to support the configuration and then the log output too. So right now at Facebook on our OS X client machines, we do use Chef to push the configuration out, which is awesome because we can write a diff and add queries to the schedule and then land that on like a certain number of machines, test it, see the performance, and then scale out to the rest of the clients. And then for the output, we're also buffering that to disk. And then we have a new syslog line that makes sure that file is rotated, compressed, has the right permissions. And then our Splunk forwarder is also looking at that file and grabbing everything back at its like leisure. And the Splunk forwarder, when I say leisure of the Splunk forwarder, like the Splunk forwarder, if the client's not on our network, it may not be able to report back. All we're doing is still pushing out the disk. It's the forwarder's responsibility to know to shuttle that back when it can. And to make sure that it like shuttles it back to the right place. If some of our employees are on the West Coast, East Coast, not even in the United States. And with that comes like an enrollment. We're really big on authentication here. There's no way to pull in a configuration or log in an unauthenticated way. You cannot put in the HTTP:// We do not want any details about your operating system able to be like man in the middle. And that's really important too because when you're running this daemon, you're running it as root. When you're listing processes, you're getting it from root's perspective. That means you're seeing the CLI, all the arguments to those processes, which unfortunately may include passwords sometimes. If you do find something like that, it's important to like talk to the people about like not running daemons that have passwords in the arguments. But we don't want to log that in a way such that someone could man in the middle, or even like another guest account on the machine could see that in the logs buffered to disk, right? Very important. So hinted at this a little bit before. What does our workflow look like? We want our workflow to deploy this to look exactly kind of like your workflow. We're OS X first, so we develop all of our tables, our new capabilities, and everything for OS X. We test on OS X, and then we go to Linux. So the concepts that we come up with and like all the diction for like processes, process IDs, startup items, it's all OS X based. And then we kind of try to translate that into what it would mean in Linux too. One day when some awesome developer sends us a pull request for Windows, we'll support Windows too, right? So we publish packages. Every time we commit, we have a Jenkins host that builds OSQuery for all of the supported distributions, and that's 10.10, Linux 12, or Ubuntu 12 and 14, CentOS 6, 7, the latest of each, Red Hat Enterprise Linux 6 and 7, the latest of each, builds each one of those respective packages and publishes them to kind of like a staging area in Jenkins. Once a night, those things are signed and pushed up to our S3, and then they're available on our downloads page on osquery.io. We pull that exact same package to deploy. We're deploying the same thing that everyone else is too. So if there's a bug someone else finds, it's very important that we come and fix that as soon as possible. And that's how we put pressure on ourselves to like support the community as well as the things that we deploy internally at Facebook. So we're pushing out every release version. So when we tag a version in GitHub, we would push that out. Now we're going to start deploying weekly. And what that'll mean is our exact scripts where we pull everything down, push out to Chef, push out to our internal Yum repos, will be available on our wiki too, if you wanted to kind of get latest every week. After that, when we want to modify the query schedule that the daemon is running so that we get new results back to pull into Splunk, we use Chef to do that, to push down both this new syslogd rotation file as well as the list of like queries that we've developed internally. On our wiki right now, we have an example new syslogd, it's actually the exact one we use, and an example list of queries that we have in our schedule. That's not the exact schedule that we have. If you're interested in the things that we're interested in, ping us. We'll be happy to share some queries that have given us high signal and caught some bad guys with you. All the results log to this like standard log location, right? So that we can pick it up with our forwarder. And then we perform all our backend, our analytics on the backend. So what does that really mean? Like we hinted at, LaunchD has a lot of specific things that you could like whittle down with a where clause or like a couple joins. We often choose not to do that. So we're fortunate enough to have a massive infrastructure where we can log a lot of data. We choose to just pull it all back. We pull it all back, and then after the fact, if there's new malware that comes out, we can then search that retroactively to find out exactly when someone was compromised. So when there are kind of like new vulnerabilities in the tables that we already have, that works really well. When there are new vulnerabilities in tables that we don't have, it's kind of this rush to push them in and then log all the data back. But this also lets us correlate with like intelligence feeds too, on the back end, not on the client. And that gives us two guarantees. One, we're doing as least work on the client as possible, so we're not interrupting people. And we are not pushing out our signatures that might be potentially sensitive to the clients too. So we keep all the signatures private and just log the massive amount of data. So we can go a little bit into the tables that we have, or let's skip that. How do you make a table? So unfortunately, the whole thing's written in C++.
It's so fast.
It's C++ because we need it to be like as fast as possible, but that creates a barrier of entry for people who want to like help extend or write new tables for us. So we've put a lot of time and effort into making that barrier of entry like as low as possible. And what that means is if you know a little bit of C or a little bit of C++, and there's something you really want to contribute, please do. We'll help you through it the whole entire way, right? We're not like those cheesy GitHub like admins that'll like critique you for not initializing some variable or something. We'll like help you out with that.
We will tell you to fix it.
We will tell you to fix it. Good catch. So the first thing that we did was kind of allow people to express the data that they want to expose in their table easy, and we do that in Python. So that's like generating a scheme, and I'll show that in the next slide. So the name of the table that you want to produce, a description of the table, each one of the columns, the type of the column, so that SQL can do like all the comparative operators on it, and then descriptions for each one of the columns. And when we write that in Python, we get two things out of it. One, it's really easy for someone to come in and describe their table. Two, we can run scripts on that to generate documentation as well. So we get this nice like website output where you can browse like the tables kind of interactively on OSQuery.io. And that kind of looks like this. So the timetable that Mike started with would be like, hey, it's named time. It has 3 columns, right? And then here's the implementation. That implementation will then be some function in C or C++ called genTime. In this case, it's pretty simple here. Look, it's C++, but you might not know. It kind of looks like Python. No, it looks like C++. Yeah, so we've abstracted a couple things away, like integer types. We have a macro for integers. Adding a row to the table that you're putting out is like row with like the really well-named columns. So we kind of take that friction away as much as possible. So that helps a lot of people too inside Facebook who are kind of C++ developers and are kind of like near the security team. If they do find something interesting, we can engage with them. And we can say, hey, it would be really awesome if you could write a table. We could then schedule a query for that and then find any of that badness going forward. And what that does for the people at Facebook who aren't really on the security team, it like motivates them to like want to kind of help the security team. So now we've taken folks who really hate us deploying agents to their machine, and now we've kind of enlisted them into our army of people that are looking for bad guys, right? If it were Python, we could probably do that a little easier, but yeah, what are you going to do?
It's worth noting that you can write, so we talked about plugins a little bit. Everything in OSQuery is a plugin, absolutely everything. All of the ways that you can configure and log with OSQuery, as well as every table is a plugin. And we have a Python module that you can use to write plugins in Python, including writing tables in Python, writing config retrievers in Python, loggers in Python. I'm more of a C++ fan than Python, so your code will be faster if you write it in C++, but if you're into Python, you've got options.
There you go.
Oh, cool, yeah, I'm up, nice. So, OSQuery is open source. That's awesome, right? So we use OSQuery at Facebook to improve our security posture. You can use OSQuery to improve your security posture as well. So there's a few things that you get out of OSQuery being open source. So the code is on GitHub, github.com/Facebook/OSQuery. You can go browse the code, contribute, check it out, make sure we're not, installing any backdoors in all of your hosts. See if you can find it. We have a pretty nice website that has a lot of nice documentation. Like Ted said, all of those spec files we use to generate really beautiful documentation on the web that you can use to browse and see what columns, what tables have, example queries, all that good stuff. It's a really good time. We also have a wiki on Read the Docs, osquery.readthedocs.org. It's really fun. So my call to action for all of you is we have a phrase. We have a lot of phrases actually at Facebook. We're chock full of phrases. One of those phrases is, this journey is 1% finished. We're really fond of that one because we have a lot of work to do both in the product and all of the other things that we are working on. So similarly to the rest of the journeys we have at Facebook, this one is 1% finished as well. So we encourage you to help us and get involved and work with us on this as we go forward. So let's build that together. And another kind of cool advantage of OSQuery being open source is that when there's a set of vulnerabilities that get released for OS X, we are the ones responsible for being able to detect the exploitation of those vulnerabilities at Facebook. So we add those detection mechanisms to OSQuery pretty quickly. So that means you get them pretty quickly as well if you're upgrading OSQuery. For example, a few weeks ago, some of you might remember there was a paper that an academic PhD student and a bunch of his colleagues released about cross-application resource access on OS X. So there are 3 vulnerabilities basically that this researcher released. One was like unauthorized access to the keychain, a few other vulnerabilities, right? And you can read the technical details of how those vulnerabilities work in this blog article that we posted, where we walk through each of those vulnerabilities, how they work, what fundamental concepts on the operating system change when those vulnerabilities are exploited, and new tables that we added to OSQuery that allow you to detect the exploitation of those vulnerabilities, right? So, and we put this blog article up like 3 or 4 days after the paper became publicized. So Ted and I were actually at a conference in Canada, and we stayed in for a few nights and wrote the tables and released them to the public as soon as we could, because there was no way anyone could detect these. There was no security product that existed that allowed people to detect the exploitation of these vulnerabilities. And to my knowledge, I don't think there is, other than OSQuery. So check out this blog article. It's on our, we have a Facebook page called Protect the Graph, facebook.com/protectthegraph. And we'll often, this Facebook security team will often publish blog articles there. It's really awesome. So it's open source, and we all win because of that. So now we have about 20 minutes left. Oh, and look, 20, it's 20, nice. So if there's any questions, please come up to the mic if you don't mind. If you're religiously opposed to coming up to the mic, we can repeat your question.
Oh, hi. Is there a Git repository somewhere with queries that you guys have used successfully, or do we have to just ask one at a time and share privately?
It's a great question. That's a really good question. Right now, today, the answer to your question is no. There is not a public repository of the queries that we use. However, stay tuned.
Yeah, that's the next step, right? That's the next logical step, yeah. We've kind of pigeonholed ourselves into using OSQuery as the one client to rule them all across our fleet, so that makes us focus all our effort for detecting badness there. The next step would be we're now spending a large amount of time working on these queries and then scheduling those queries. Just like we did with this, it would make sense that we start sharing those two and kind of put a little bit of engineering effort around some way to share them and coordinate, communicate. Yep.
Originally, when we first were writing OSQuery, the idea was that we would kind of write all these tables that were very generic and easy to use, and people who were interested in using OSQuery would then take OSQuery, read the documentation, and kind of have some fun with OSQuery and come up with these queries, and then distribute them across their infrastructure, and everyone would kind of do that on their own. And one really common thing that we get asked is exactly that. So we often take feedback from other users of OSQuery and try and set goals for the team to solve those. So I don't want to give anything away. So stay tuned. Stay tuned. Yeah.
2 questions. One, do you anticipate any issues with rootless under El Capitan? And 2, I saw you also had tables for Yara. Have you effectively replaced Midas with OSQuery?
I'll answer that one first. So I wrote Midas. Yeah, don't use it. So I used to work at another company before I worked at Facebook, and I worked on host intrusion detection there as well. And the product that we created, the tools that we created for host intrusion detection, we released part of it as Midas. Now, there are a lot of reasons why Midas isn't a really great piece of software. And actually, so I gave a talk at Velocity in Santa Clara a few weeks ago, and that talk was all about open source and security and how they mesh together and all of the cool things therein. And a big section of that talk was kind of like a post-mortem, lessons learned from Midas, and actually a lot of the mistakes that we made with Midas. When we started making OSQuery, we fixed all of them. So I strongly recommend you using OSQuery. It has all the features and then some.
So for the first part, for rootless, yes, definitely problems ahead. But we'll definitely document everything on our wiki. Our wiki, under the deployment section, is like exactly how we deploy at Facebook. So once we figure that out, we'll put it right up there, ASAP.
And Yara,
Yara.
we have a bunch of, so Yara, we have a awesome contributor to OSQuery named Wes, who's he's a member of the community, he works for another company. He's just a good friend that thinks OSQuery is cool, and he's also so happens to be a core committer to Yara. So he added a bunch of event publishers that allow you to specify similarly to how you can specify, all right, I want to watch all of the files in /bin, and I want the changes in those files to be emitted to the file events table. There's also a Yara events table, so you can say, all right, I want all of those files that I'm watching to be checked against these Yara signatures. And if they match, if your Yara signatures indicate that the files that you've said you wanted to watch match, then they get emitted into the Yara events table. So there's native Yara support built into OSQuery directly, yeah. And it's documented on the wiki if you want to check it out.
Good question.
Good question, yeah, excellent question.
My question more strategic, just to help me get an understanding. It seems like OSQuery is more like reactive. It's checking the things that happen and then reporting on things that you're watching and reacting. Whereas like a traditional antivirus or things like that more is proactive, where the user tries to do something and it stops them from doing that. Pros and cons to that, and
great discussion, yeah. So we've only had select statements in OSQuery, and that's all there is. There's no like updates or inserts. It's a really hard problem, but we're not like adverse to it. It's like not on our milestones or on our roadmap to make it like take actions, but we could definitely see like an insert, like an update. We've kind of played around with things called like action handlers. So like you could do something in response to something being emitted from a query. But we kind of backed off that a little bit because you could kind of do that on your own without changing anything inside OSQuery. Just like pipe the results to something taking an action. But yeah, for the most part, we know incident response like really well. So we kind of like have focused on that.
So, to add to that, philosophically, now we're strongly venturing into the realm of opinion now. However, philosophically, I think that traditional, when you think of traditional security software and you think of that, I want to do this thing, and piece of security software knows me better than me, and it's telling me I can't do that thing, that's never a good experience. It's always a bad user experience. If you're trying to do something and a piece of software is telling you you can't do it, that sucks. And nobody is going to like having to interact with a piece of software that way. Additionally, if you want to block actions, you need to be 100% sure that you're always going to be blocking actions that are 100% legitimate, or else your users are going to be angry, right? So if you are detecting actions and then doing behavioral analysis on the metadata that you collect, you can collect a lot more information and collect information much more liberally than if you had to prevent on all that information as well. So it's kind of a philosophy thing of strategy of how you want to approach security with regards to user experience and general security strategy. But I think that we don't do the whole traditional security prevention. We focus on detection rather than prevention, and that's very much by design.
This is not necessarily an OSQuery question as much as it is a detection question when it comes to security. It seems like you have the tools in place to send all this information to one big master log. How do you keep the noise out and actually point out what you think is an actual concern based off of that? Are you using having you Splunk? So I'm not sure if it's got the tools in there to help you set certain parameters to say, hey, make this pop out. I know that a while ago with the big Target breach that kept getting things that were like warnings, but everything was the warning. So you got to attack it, I think, with sort of like a a surgical knife more than a hacksaw in terms of like figuring out how to determine something's really an actual threat. And we've used everything to gather all this information, but we got to make decisions on the right things that were logged in there. So I'm not saying exactly how you do it, but in terms of like philosophy or approach in general, that could be sort of generalized if you could share that.
Yeah, we have like two philosophies on that. The first one is like we treat this like a sieve. So your first opportunity to reduce the amount of noise would be coming up with like really nice queries. The second is having them only log the differentials of the output. And then the third would kind of be the application of IOCs or signatures on the back end. We like that model a lot because we can retroactively apply new signatures on the back end if we're collecting a lot of data. So the thing that turns into like an actionable alert for our incident responders and for us would be like the matching of that data, right? And then when we're like an incident handler, when we're having some fun and when we're exploring the data, that's when we're coming up with like new learning techniques to look at it, or like new anomaly detection techniques to look at that. And what that'll turn into is kind of like a daily or like a weekly hit list, right? And these are the things to go investigate. And from there, we'll iterate that one last time and turn those things that are like always something that we investigate into like the signature or into the alert.
Ted's responses are much more pragmatic than mine.
I'll tell you what we do today, yeah.
Yeah, I'll tell you about something that I thought of while I was sleeping. But so another thing I think that's important to keep in mind is that it's really easy to think about logs as an event stream that a human should be reading. And I really, like, humans shouldn't read logs. I feel pretty strongly that humans should never have to read a log stream. Humans aren't meant to read log streams. That's not how humans recognize patterns and anomalies. You should think of the data. OSQuery generates data. And that data can be arbitrary. It can be whatever data you want it to generate. And what you alert on is based on the questions that you ask the data. So if you schedule a query that's like select star from launchd, where path equals like known bad path, then every result that query generates will be known bad, right? But if you schedule a query like select star from launchd, now you're collecting an event stream of the mutations of all launch agents on launchd across your entire infrastructure. Now that's really valuable data to have, and those mutations may indicate certain things that are bad, and you should then ask pointed questions of that data set that indicate compromise with a high amount of signal based on the total aggregate data that you have. So I think it's more of a data analytics problem, and kind of like the hard part is getting this data, and then once you have all this data from OSQuery, ideally, then you can ask really interesting pointed questions of that data that are very high signal, that don't result in much noise at all.
I have two questions. One is I'm not acronym compliant, so this should be quick. IOCs are what?
Oh, sorry. Indicators of compromise.
Oh.
So that could be like an IP address, a domain name, a path, name of a process, just some like detectable artifact left on an operating system.
Cool. I think you mentioned ISEs as well as possibly a threat or criteria of...
Oh, no. I would probably just mispronounce IOCs.
Pardon me. Thank you kindly as well for adding the browser extension plugin detection.
Yeah.
Rock plus roll. And then yesterday we made some decisions in here about authorization plugins. And one of the things that go into doing that is you have a bunch of plugins that are there by default. I see on the issue page, master tasks, SQL tables, requests, and roadmaps that there is an authorization DB config. Mm-hmm. That is what that refers to, possibly?
No, yeah, that's us getting the authorization DB data represented as a table. Yeah, but we don't have that yet.
Ah, gotcha. Yeah. So I'll follow it.
All of the bullets in that master task represent like ideas that people have said, like, hey, it would be really cool if we had a table for this, or really cool if we had a table for that. So that's our master task for table requests. And then we check them off when we do it. If you're interested in contributing to OSQuery, then like number one way is the actual, like when we get interns or new employees on the team, we always have them write a few tables first because it's like the best way to get introduced, the best and easiest way to get introduced to the code base. So if anyone's interested in contributing to OSQuery, check out that issue and that GitHub issue, SQL tables master task, and pick one out and have fun with it.
I have so many questions that I just keep checking for people behind me. It's not that I'm paranoid that the mafia is after me. I also want to know how much time we have. Nate, I've had discussions with him because he's my bro, and he had said that one of the things that is difficult with other tools that say they're going to log application usage is that they don't know what the frontmost application is most of the time. Plus, they're naively checking for known paths, and therefore they don't see stuff in dot fold. Anyway, unclench. There is a way to detect that it is the frontmost application and log events for those times?
Yeah, absolutely.
Time windows?
We can get all NS Notification Center APIs. There's a lot of data there, and it's structured, but it's not uniformly structured. So if there's something you want out of a certain Notification Center event, such as an application change to the front, yeah, we can put it in there.
So it does not currently exist?
No.
Okay.
Yeah.
I'm just following the issue right now.
Yeah, I'm pretty sure there's
please do.
I'm pretty sure there's an app delegate handler that will specify when applications move to foreground and background. So we can almost definitely hook that the same way we hook application opens and closes. But yeah, if you want that, totally make an issue and we'll add it.
Anybody wants to line up behind me, please do feel free to. All right, I'm going to keep going.
I'm just going to ask a real short question so he leaves.
What day is it?
I did actually have a quick question. So one of the wow, I'm too tall for this. One of the problems with a lot of AV is the on-axis scanning that can severely impact specifically bootstrap phases where you know what you're installing, yet it's checking everything. Do you have any rough ideas of how much quicker if you use the general file checking axis? Is it much faster, same? What are your experiences with that?
Yeah, so right now on OS X, the only file modification change API that we're hooking is FS events, and that's the lowest priority change eventing system, and lowest priority up to the fact you may not get the event, right? So the impact is actually, we measure impact by watching the system time and user time for all hosts. So one of the queries that we have scheduled actually looks at the schedule of queries, and in there we have the average memory each one of the queries is taking, as well as CPU performance. And then we'll graph those and chart those per machine, so the machines that are going out of whack, but then on average too. So if something goes crazy to the point where we think someone might be impacted, we'll take it away. We haven't seen that. So I can't comment comparatively between FS events and something like vnode or koff yet. That's the best I have.
Okay. Ideally, the way that we get any data is the absolute fastest way to get that data. It's one of the charters of OSQuery is performance above everything else, which is actually why we chose to. One of the reasons why we chose to go with SQL instead of Python or something is because you can use SQL and we just hook into a SQL engine. And under the hood, we're at runtime executing assembly, right? Compiled C++, so it's super fast. So we generally try to be as fast as we can, as much as possible.
One more note, I know we have 3 minutes and stuff, but we also use all of the priority scheduling syscalls to make sure that we have the lowest priority for disk access, as well as scheduling, so we really don't get in the way.
This might be completely out of scope for this project, but is it possible to use OSQuery to query a remote device?
Not out of scope.
Not out of scope at all. So
hard problem.
Hard problem. There's a really cool open source project called EnvDB, which allows EnvDB, which allows you to do really cool remote querying via WebSockets. And that's really neat. We're working on something very similar internally at Facebook, and it's not at the. It's not. Stay tuned. Yeah, stay tuned. But right now, the OSQuery public repository contains the OSQuery I and the OSQuery D binaries. And there are open source additions that you can use to allow you to do a lot of extra functionality like that. But as far as like supported from us that work at like that known work at Facebook scale, stay tuned. And cool, yeah, so we're now officially into the seconds part of the countdown. So thank you all for coming. There were a lot of talks that were awesome at this